Today we're going to be talking about angle relationships. Keep in mind that in order for angles to have relationships, there has to be more than one angle involved. Just like you can't have a relationship with yourself, an angle can't have a relationship with itself. It just exists. So there has to be two angles or more in order for there to be a relationship present. First, we're going to talk about adjacent angles. Okay, so let me write that up here, adjacent angles. And adjacent angles have to lie in the same plane, okay, and they have to have a common vertex and at least one common side, but they're not going to share any interior points. So for example, this point here, call it point 1, and this angle, angle 1, and this angle here, which we'll call angle 2, they are adjacent. They share this common vertex together, and they share this wall, right, this common ray, okay? But you'll notice that they don't overlap at all, right, and that's really important. So when we're talking about adjacent angles, they have to share a common vertex, like this one down here, and they have to share a common side. It's kind of like my classroom and Mrs. Benning's classroom. Our classrooms don't overlap at all. You can't stand in both my classroom and Miss Benning's classroom at the same time, but we share one wall. So the wall where my filing cabinets are is the same wall where she has her computers, because we share that wall. Okay, so those are adjacent angles. Next, we're going to talk about linear pairs. Okay, and remember how we talked about the root word of linear is line? So that's going to come back to help us now. So a linear pair, they have to be adjacent angles, and so you're going to notice that here again, they share common vertex, and they share one common side. And then what makes them linear is that the side that they do not share is going to make a straight line. Okay? And that's going to be really important. What that's going to tell us is that if you add these two angles together, they will equal 180 degrees. Okay? And that's going to be really important as we go to solve some problems today. So keep that in mind. They have to be adjacent, so they have to have that common vertex, and they have to have this common side. And then their non-common sides has to make a straight line. Okay? And that means that they will add up to be 180 degrees. Okay? Next, we're going to talk about vertical angles. And vertical angles, we usually think of the word vertical, meaning up and down. And the key here is going to be to remember that angles could be rotated. So if you could make them up and down from each other, if you rotated the picture, then they will be vertical. And so vertical angles, I think it's easier to think of as being across from each other on the x. So if I have an x here like this angle and this angle, we'll call them angles 1 and 2. These are vertical angles. Okay? You'll notice that if we rotated the picture, then this angle over here and this angle over here would also be vertical. If you turn your you're able to, like if you're on a tablet or something, you could turn your screen and you would notice that these are also straight across from each other. So we'll call these angles 3 and 4. So both of these are vertical angles. So angle 1 and angle 2, can't read my own writing, angle 2 are vertical angles. And then angles 3 and angle 4 are vertical angles. So you have two sets of vertical angles here. I do want to give you an example of something that is not a vertical angle as well. I know that can be, these are a little bit more confusing. So let me clear these. Just a second. Okay. If you had something like this, okay, you'll notice that we don't actually have an X anywhere in here. Okay. On this picture, you do not have any vertical angles.
Testing 1, 2.
No vertical angles. you might even want to add up into your title on this section that these are not vertical angles. You'll notice that there's no X that's created, that they're not straight across from each other, and so that's going to be really important. The one fact that we do have that's really helpful, because vertical angles show up for the rest of the year, is going to be that vertical angles will always be congruent. And so that does not mean that every congruent angle is vertical, but if it meets the criteria, if it looks like that X, like we were talking about just a minute ago, right, where you have this, and you're looking at those angles across from each other, it's going to be really helpful to know that these two angles are going to be congruent, meaning they're going to be the same size. And that's going to help us solve a lot of problems this year. So keep that in mind as we go through these. Next, we're going to talk about some special angles, or angle pairs, excuse me, that add up to special numbers. So our first one is complementary angles. And complementary angles are always going to add up to 90 degrees. These are complementary angles. You're going to have, like angle A plus angle B, and they will add up to 90 degrees. In a picture, that might look something like this. You would have this, and it might be divided in half. You might have an angle bisector, you might not. So it could be that this angle is 30 degrees, and this angle over here is 60 degrees. Okay. And then we would be able to say that these two angles are complementary because they add up to 90 degrees. You might also know that they're complementary because they might have a right angle box drawn on there. And so they might still have it divided up into two parts, but you would know that they're complementary because there is a right angle box on there. Okay. Next, we have supplementary angles. And supplementary angles are going to add up to 180 degrees. So we have angle A plus angle B is going to equal 180 degrees. And if we were to draw this out in a picture, I'm going to give you two pictures for this one. The first one would be a linear pair, because they are always supplementary. Okay. And so I might have a 70 degree angle over here and a 110 degree angle over here. And that would be supplementary angles. But they don't have to be connected. And so I could also have something that looks more like this and this. And so this one might be a 100 degree angle, and this one might be an 80 degree angle, and those would also be supplementary because they would still add up to 180 degrees. Okay. So we're going to use this to be able to solve some problems. Our last one is going to be, it's lines, and I know that that's a little bit confusing because you're like, wait a second, we're talking about angles. But perpendicular lines are something I'm pretty sure you've heard about before. And if you haven't, then they create 90 degree angles. So if you have perpendicular lines, we have two that fully intersect, you're going to notice that they will create 90 degree angles all the way around. Okay. You can also have perpendicular lines where you have a line segment that's intersected here. And so you might just see this top half. So the bottom of it still exists, right? We just chose not to draw it, but it still exists down there. And so you might see it look like this also. And I also want you to know this upside down T, the way that this one looks, that is actually the symbol for perpendicular. So if you were to see lines written as, line AB is, and you have this little upside down T, that means perpendicular to line CD. That would mean I have two lines here and they're perpendicular to each other. Okay? So tomorrow in class, we're going to practice with these and we're going to use some of that information. So please be sure you have these notes with you in class because it's really going to help you out. Thank you for listening, and I hope you have a wonderful evening. Bye.